Good afternoon, everybody. Welcome back to another live stream. Today, we are going to be talking about an interesting topic, a topic that's been very popular in the public this year. Many of people have labeled this the year of AI agents. And so I know it's September. And so you might be wondering, why is it taking me so long to get around to this? And to be honest, we're going to be talking about agents. So like just to give you I labeled this as part one. Today's going to be just like a high level overview, and then in future streams we'll delve into more things, and we'll end today by coding up our first basic sort of agent using a singular agent framework. But what I want to cover today is the general conceptual idea behind what an agent is. And then I want to cover also when you want to use it and when you may not want to use it. And so I'm going to get ahead of myself a little bit here. And I'll start by saying you don't actually necessarily want to jump to an AI agent as your first go-to solution. I would actually say this should be more of a last-ditch kind of effort. And so, yeah, let's go ahead and talk about that. So let's talk about first, what is agency in general? So setting aside AI and everything, let's just talk about what is agency. So the bare bones definitions of what agency is essentially somebody, or I guess an entity in this case, doing something else on your behalf. And what do I mean by that? So if you think about, all the different contexts in which you work with agents in your typical life. And again, we're just talking generally speaking here. We're not necessarily talking about AI agents per se. So you might have an insurance agent. You might have a travel agent. You might have all these different kinds of agents. So if you think about like an insurance agent is generally a person that operates on behalf of an insurance company, and they're working with customers and such to sell insurance products. Auto insurance, home insurance, life insurance, health insurance, etc. What they're not selling you is pizza. That sounds kind of stupid, but generally speaking, when you think about agents, they are operating in a capacity, or they can operate in a spectrum of a capacity. Like, so with insurance agents, they are fixated in the insurance domain. With travel agents, if you were wanting to help book a vacation or something, this is somebody that's working in the travel domain. And the reason I bring that up is I'm not necessarily going to cover this today, but as you can kind of get a sense with those general things, or let's actually not, we used explicit agents there. Let's talk about people who act in agentic capacities but may not have the title of agent. So for example, an executive administrative assistant. An executive administrative assistant is probably doing they're probably working for some sort of executive or the CEO or something like that. And they are doing activities that maybe go beyond what like an insurance agent or a travel agent might do. In fact, they might be doing a little bit of both. So they're probably, helping to book meetings. They're probably interfacing with different partnering areas to get, things kind of worked out on behalf of a CEO or whatever. So that in that kind of instance, an executive assistant does a lot more on behalf of somebody else than like a travel agent or an insurance agent or things like that. And so the reason I want to bring that up is just to recognize that there is a spectrum of agency. Excuse me. And for this, the purpose of this stream today, I'm not necessarily going to cover that spectrum. I do want to, in a future stream, actually talk a little bit more about that spectrum. And to be clear, just as like a heads up here, there is not an industry defined standard on what that spectrum of agency looks like. I personally like how Hugging Face has laid it out in whenever. Do I want to talk about that right now? No, I don't think I want to talk about that right now. By the way, I am taking questions on LinkedIn or YouTube if you have any questions, so feel free to drop them in the chat. I'm happy to answer anything as we go along. But what is an agent in the AI capacity? So we just talked about how agents, generally speaking in the world, operate on your behalf to do an activity for you. So when you think about an AI agent, what we want to build is essentially this unit that we give a number of tools to, and then we set a task or basically have it complete that task in whatever way it sees fit. As you might think about this, so the most popular form of agent today is actually a coding agent. Actually, let's go ahead and jump into my screen here, and let me just demonstrate this for you using GitHub Copilot. So I'm just gonna create a new random here. I'm gonna create a new random file in here. Let me make this bigger for y'all. Okay, in fact, it's so big now that I don't even need my glasses. All right, so let's go ahead and say I'm going to create a new folder in here. I'm going to call it test. And let's just think of some random test here. Let's say I want to build, I don't know. Here, so what I'm going to do here is just demonstrate GitHub Copilot. So you can see here, I've opened up on the chat here. You can see we have GitHub Copilot here with agent mode. And so what we can do here then is we can say, I don't know, help me to build an API in Python with 2 endpoints. The first endpoint should be a post endpoint that accepts any old string as an input and returns a string that says this is your input followed by the input. The second endpoint should be a get endpoint. I just realized you can't see what I'm typing because my face is in the way. Let me get my face out of the way. The second endpoint should be a get endpoint that essentially serves as a health check endpoint. Now, what I'm typing here is neither here nor there. What I want to highlight here is, my face is once again in the way. You can start to see as the code starts to go through here, then it's going to continue to do different activities. And my face is going to just keep getting in the way. So apologies. I'm just going to have to keep moving my face out of the way here. But what I want to highlight here is, so as you could see, we have a Python script here. It's using Fast API. And you can see now that it is saying, okay, we created the script. Now I need to ensure that I need to install these dependencies. And so what's essentially going on behind the scenes here with a coding agent is it is doing a couple different operations. It's doing some reasoning and thinking. And then we've also given it the ability to look at other code files within a repository if we need be. Now, in this particular example, we did not need to. But there are examples in which you might want to code something and then you want it to be compatible with another piece of code in your repository. So it's going to comb throughout there and look for those. And then you can see here, we actually have the agent has the ability to recommend commands that it can run. So in this particular case, it is trying to install some packages that it might need. In other instances, it might be running some test cases, or it might be trying to just run the code itself, or compiling actually, one of the really interesting things that I've seen the coding agent in particular do, is it will, if it's not sure what the capabilities of like a third-party library like Fast API or Pydantic, as you can see here, what it will sometimes actually do is it'll run like this little bit of a test script to like actually see, okay, I've imported this from Pydantic, I've imported this thing called base model. What can I do with base model? And it will actually run that here. So what I want to highlight here is in the context of a coding agent, we basically given it the ability to reason. We've given it the ability to look at other code within our repository here. Actually, the GitHub Copilot implementation, you can give it online documentation. It will go out to the online documentation and find something that may be ambiguous, etc. What we're not telling it is we're not telling it you must follow these explicit steps. You must follow A, then B, then C, then D. That is not what we are doing here. We are and that's the whole idea of AI agency here, is we give it a task, we give it the tools it needs to complete the task, and then it solves it solves for the problem in the way in which it feels is the most appropriate. And so that is a very simple example of agency, holistically speaking. Now, why am I not necessarily wild about, or one to necessarily jump at AI agency here? And I'm going to use a very simple example. So back in high school, I used to work at a Steak and Shake, and I was at a drive-through operator. And so I'm sure everybody's been through drive-throughs, and all drive-throughs work a little bit differently, but more or less, this is the process in which you go through, in which you do these things. So car rolls up, they place their order with the drive-through operator. So they place the order. They will roll up to the first window. At Steak and Shake, actually, there's only one window. So the first, let's actually use McDonald's as an example. So because more people are probably more familiar with McDonald's. So if you roll up to the first window with McDonald's, you pay for your food, and then you wait. You continue to creep your car a little bit forward, a little bit longer, and then you make it up to the second window. And with that second window, they hand you your food and you drive off. So what I want to highlight there is those are very sequential steps. And it's very intentional why McDonald's or why all these fast food businesses have applied this model to the drive-through framework. It's because of it's optimized, it's fast, it's easy to train these people to say basically, when I started, like I said, I was a high schooler. I think I was 17 years old maybe as a drive-through employee. You could train a 17-year-old or a 15-year-old or even younger to operate a drive-through relatively easy because you have these set of steps. And so if you think about most business processes follow a sequentially ordered set of steps. You do this, and then you do this, and then you're done. With AI agency, with agency in general, you are basically saying, okay, here's the freedom to basically solve the task as you see fit. And there's risks to this. There's risk to this because we can't guarantee that the agent is necessarily going to do what we want it to do. And that is why I'm saying I would actually jump to automation first in the AI capacity over agency. And that's not to say there is no case for an agent. In fact, we just proved that out right here. We proved that out with the GitHub Copilot example, where AI, because it is so loose on how we are operating. In this particular case, let me go ahead and share my screen again, where we were creating a very simple API. We needed it. There was not a sequential order set of steps. So I mentioned before that GitHub Copilot does have the ability to reach out to the internet to grab public documentation, but it only really does that in cases where the code is ambiguous. And in this case, it is using Fast API and Pydantic, and these are two libraries that are very known, very familiar, and thus you did not see GitHub Copilot reaching out to the internet to try to get the documentation, and that makes sense. And so there is a realm or a place for agents. It's just that I would not necessarily recommend it as like your go-to kind of thing, or your very first. We must land with agency. And the other thing that is also a bit concerning with AI agents is this idea of AI observability. What do I mean by that? So with a typical, any of these other sorts of things that we've coded in the past. In fact, I've got a couple things open in here. What have I created in here? Excuse me. Looks like I've created some things in here that are not necessarily. What am I trying to say? All right, let me find something in here. So, I forgot. We did this. We had this particular example we did a couple streams ago where we just generated some data. So just as a quick reminder, what this was doing is basically we were creating a list of the 50 U.S. states in alphabetical order, and then we had it extract but you could see here, so we used LangChain here. LangChain allows us to specifically set those steps of first do this, then do this, then do this. So you can see here by this line that I'm going to highlight that our chain is doing three things. First, we are ingesting our template, then we are passing that to the chat model, and then we are taking it as an output parser. We want it to follow those three steps every single time. And in many cases, this will suffice for many of your business processes. And actually, I would recommend this kind of pattern over, again, jumping to agency. And we will highlight a specific example where I will hopefully be able to demonstrate where an agent fails and why there is risk associated to an agent. But I got to be very careful here because this is going to sound weird, but a couple weeks ago, I was at a public environment. It was, well, I don't know what I want to, if I want to say what it was. It wasn't work related. I'll say that. But somebody in that public environment accused me of being anti-AI, and I'm not anti-AI by any means, or anti-agent. I am pro AI, but I am pro using it in the way that you should be using it. So in some cases, an agent makes perfect sense, but in many cases, you don't necessarily need an agent. Okay, so that is a very high level introduction to agents. So let's actually talk about a little bit how AI agents work. So this is the Strands documentation. I'm getting. Don't worry about what Strands is now. We'll get to that in a little bit. But they did have this conceptual diagram that kind of demonstrates relatively easily how an AI agent works. So basically, you pass in your input and context here. So this could be and let's just use the coding agent kind of example, since we already recognize this. So in this case, the input would have been my prompt. It would have been the thing that said I want to create an API with 2 endpoints, etc. And then we basically pass it into here, and then we have the large language model do the reasoning to understand, okay, what are we trying to do here? And in this case, so we were trying to build an API, so it may need to invoke some tools, and so those tools could be anything. And in the case of GitHub Copilot, again, some of those tools are going to be, can I look at whatever code else exists in the repo? Do I need to do some reasoning kind of things? Do I need to reach out to the online documentation? Those would be 3 examples of tools that it could possibly invoke. And then you can see here down on the bottom that we have the actual tool execution, and then we have the kind of like a circular loop going on here where it continues to do this loop until it converges on the final response. And then once it converges on the final response, then you return that back. Now, the other thing to highlight here is, so we noted in this specific example 3 particular tools that it could use. It could actually, it's one of these things where you could have in a single invocation, like a session, I guess, if you will, an agentic, what do they call it? I think I think the actual verbiage is called a cycle. In the cycle, you could have it invoke only one tool, one of those 3 tools, or it could invoke 2 out of 3 tools, or all 3 tools, or it could just invoke one tool like 5 different times and ignore the other tools. And so in terms of AI observability, what is really important here is to recognize that we need to have an understanding of what the agent was doing throughout its process. And that way, that could help us to debug if there's like an issue within our agent, or it could also help to explain why an agent produced its certain behavior, because then we can see the full trace of, oh yeah, it took this step, it took this step, it took this step, and then it took this step, and then finally converged. And so that is not as clear as like this line of code here. In this code here, in this chain that we developed, we know what the steps are. We know that it first went to the prompt template. We know that and then we invoked the chat model, and then we passed it to the output parser for the output. So this is rather transparent. Now, again, there is the whole, all AI models are black boxes in and of themselves, so that is neither here nor there. But when I talk about AI observability in the agentic capacity, I'm talking about what tools did it invoke, when did it use reasoning, what resources did it make use of, etc. Okay, so that is an extremely high-level introduction to agents. So let's go ahead and code up a very simple agent, and we are going to use the Strands framework. So this is actually the documentation for Strands. Today we're going to focus on Strands, but just be aware, Strands is not the only agentic framework. There is, but the industry at large is not settled on a preferred agentic framework. So there's, we will also cover at some point, not today, small agents. So that is Hugging Face's implementation of an agentic framework. We'll cover LangGraph. We'll cover perhaps Crew AI. I'm trying to think what else. There's another big one in there that I'm probably forgetting. But those are probably some of the big ones. I would say, generally speaking, the 2 I am leaning on recommending would be Strands or LangGraph. And so specifically, the reason I like Strands is it just is the simplest to use. Well, there's 2 reasons. Number one, like I said, simplest to use. very straightforward to understand. And this is also the framework that, so I'm not sure if this came from AWS or if AWS, Amazon Web Services, or if it was, I don't know. Basically, what I'm trying to say is this is the framework that AWS is recommending. I don't know if it came from AWS or they just have some sort of partnership. So because I, in my day job, work a lot on AWS, naturally speaking, I would want to be using the framework that AWS recommends the most. Now, just to be clear, for example, AWS recently came out with a service. It's still actually in preview mode called Bedrock Agent Core. And the way that I can describe Bedrock Agent Core is more or less, hey, bring your own agent kind of framework. And in fact, if you go in this documentation here, you can actually see, I know it's in here somewhere. You can actually see where it, yeah, here we go. You can see where it has like the documentation of how to make it work with Bedrock Agent Core. But the thing about Bedrock Agent Core is and I think I won't cover Bedrock Agent Core today, but in my playing around with it, it is not exclusive to strands. So, meaning that you can use LangGraph, you can use Crew AI, you can use basically any agentic framework that you prefer. So that's strands. And we will, and for today's purpose, in terms of the code, we will focus our attention on strands. I do want to give a special call out to LangGraph though. So to be transparent, LangGraph, so as the name kind of implies, LangGraph is created by the same company that created LangChain. And if you've been following with me for a while now, you know that I've used LangChain quite a bit. There is a plus side and a downside to LangGraph in particular. With the plus side, well, we'll start off with the downside. The downside is it's really hard to code. It's just the syntax is kind of weird. It's just a lot. It's not super straightforward. But the benefit of LangGraph that I'm starting to appreciate a little bit more now that I'm starting to delve into it more is that, as the name implies, with the graph name in there, is that it is a graph-based framework, meaning that essentially you are creating DAGs or agentic DAGs using LangGraph. So if you don't know what a DAG is stands for Directed Acyclic Graph. It's essentially you set up these nodes and the edges to the nodes, and you basically can set up a very particular way in which you want to create your agent. So for example, you may say, okay, when an input comes in, I want it first to route to one of these two nodes. And then if it goes to this node up here, then maybe I want it to operate against 3 more nodes over here. And then with this latter set of nodes, maybe I only want it to do 2. So basically, that's probably a poor way of explaining it. But essentially, LangGraph allows you to get really granular with how you are using your tools. Whereas if you're not as interested in that level of granularity, I would actually recommend strands, because strands is super, super simple to work with. All right, so let's go ahead and jump into the code here. And let's go ahead. I'm going to create a new notebook. I'm going to call this, livestream notebook.ipynb. Okay. All right, and just for context, we are going to be making use of OpenAI as the backend model here. Oh, that is one gotcha that I ran into with OpenAI this last week, and I don't know if this is a new thing or not. Essentially, when I was trying to go through OpenAI using the API here, let me go ahead and log in to kind of show you what I'm getting at. All right, give me just a second to log into the platform here. Okay, so if we go up to the settings, I think it's the setting. Okay, so you can see this piece here where it says verifications. So it's like I've always had these API keys set up and such for like months, or some of them even years, which is weird to think about that I've been interacting with these things for years now. But when I was trying to do my testing earlier this week with the OpenAI API, specifically trying to invoke GPT-5, I got an error message that noted that I needed to have my organization verified. And what that entailed was going into this user interface, and when I obviously it's already done now, but when I went into here, I actually had to take photos of my driver's license and stuff. And yeah, to basically get formally verified, so that was new to me. So like that's kind of neither here nor there for this stream. I just wanted to call that out, and just in case you've been working with the OpenAI API and you might be wondering, well, why is my API not working? You may have to go and verify your organization. All right, so I do already have my API key downloaded. So I'm gonna go ahead and do a couple imports here. So I'm gonna import. Let me select my kernel just to make sure that we're good to go here. Select my kernel. I forgot I operate on 2 different systems, so I probably do need to ensure that my source is good. So I've been using my virtual environments here good, so I'm going to do, what's the command? UV sync. That's right. All right, just making sure that all my dependencies were installed appropriately. Okay, so I'm going to do a couple imports here, and then don't worry about the imports for now. We'll talk about these as we continue along. So YAML has nothing to do with the agent itself. That's really just for me to, because I have my API key stored in a YAML file, so that's really just to load the YAML file. From datetime, import datetime. So we'll get to why we're going to be using this. And then to actually make use of strands, so we're going to do from strands, import agent, comma, tool. So we got those 2 things there. And then from strands.models.openai, import OpenAI model. Okay, so that's all of our imports there. Now I need to load up my API key. So with open... This is going to look a little bit weird, but this is where my API key is stored. API keys.yaml, YAML, R as F, API keys equals YAML.saveload F. Now let's go ahead and set the model. Model equals OpenAI model. And then I'm going to say, so this is how you set your API key. So we have to set our client arguments. Our client args are going to equal API key. API key is API keys OpenAI API key. So this is just again, for my purposes, I am keeping my API keys loaded into a local file. Again, I am using a gitignore file here to intentionally not push up these keys. So you can see here, my API key is actually stored in this grayed out directory. And the reason it's grayed out is because I've intentionally had my gitignore file not push that up here. All right, so let's close that down. And then we need to set the model itself. So for the model, I'm actually going to set GPT-5 Nano. So if you're not familiar, there actually is a nano variant of GPT-5, which is like the cheapest and quickest, but not necessarily the most intelligent. All right, so that's how you set your model. All right, what did I do wrong here? What did I do wrong? Where's my, maybe I have it in a weird place. Up. Okay, so I'm in here. You go up here. All right, so we're in this directory, up1, up2, keys, .api keys.yaml. Hold on, let me check here. What? All right, there's some funny business going on here. No such file. All right. I probably have something kind of goofy here. Let me hold on just a second. I'm just going to copy and paste from my other file here to see like why. Okay. I don't know what I did there, but it was just probably some silly typo. But anyway, so that we've set the model. Now let's go ahead and start creating some tools. So again, we talked about, let's go back to our picture here. Where's the picture that I was referring to here? All right, where's that picture? Come on. There we go, this picture here. So again, recall, whenever we set up one of these agents, we want to set up some tools that it can invoke. And again, for our purposes today, we're going to keep things really, really simple. So let's talk about some things that large language models do not do natively, or should not do natively well. Number one is because these models are trained at a snapshot in time, it does not know the current date and time, meaning that so if you go to ChatGPT, ChatGPT is probably an agent in and itself, and what I mean that is so it doesn't know the date and time, but perhaps it's doing something behind the scenes that would grab the date and time. So it can't do date and time. What else can it not do? It can't necessarily do mathematical operations. Let's actually demonstrate that. So if I go to open a multiplication table LLM. All right, this is the image that I like to kind of reference here. So this is a little bit of an older image, but it's still kind of relevant. So this is demonstrating the accuracy of the O1 mini model that came out over a year ago. Oh my gosh, I feel so freaking old. I can't believe it's been a year now since this has already come out. But basically what this is highlighting is when you have a 1-digit number times a 1-digit number, an LLM does okay. Or it does pretty well. I'm sorry. It does very well, actually. But as you notice, when we start to get up into really big numbers, then we start to see a drop off in accuracy. And this is just the nature of large language models. Large language models are essentially next word predictors. And so whenever you have a next word predictor, there's actually no actual mathematical calculation going on. So when you ask what is 2 plus 2 to ChatGPT, yeah, it's going to get that right. But it's only going to get that right just because it's seen. Again, large language models are trained across all internet public data. All internet public data has always said 2 plus 2 equals 4. Like, of course, yeah. So it can't do date and time. It can't do calculations. What else can it not do? It cannot do. Hold on. I'm just checking to make sure. Yeah, we're just going to focus in on those two. We're going to just focus in on date and time, and yeah. All right, so how do we address that? So we're going to create some tools so that the agent can use. So that way, instead of trying to invoke the model, we're just going to have it try to use these tools to actually produce the answer in a programmatically correct way, if that makes any sense. So with strands in particular, they make it extremely easy. So basically, the only thing that we need to do is create some functions that will do this for us, and then decorate them. And so if you're not familiar with what a decorator is, a decorator in the Python sense is basically when you when you have like a Python function, and then right above the Python function, you do like an @ kind of thing. So like Fast API, this is really popular with Fast API. Whenever, do I have any Fast API? Hold on. I'm sure I do. HTTPS. GitHub.com/DKHundley. All right, I'm sure I've got a Fast API thing in my Titanic. If I can spell that right. All right, so in the Titanic repository. All right, and if I come down to here, API. Okay, so here's what I'm talking about. So basically, when we create a Fast API instance, we create the functions themselves, and then we decorate them with the @ thing up here that notes, okay, that we want this to be a post endpoint at the invocations, and we want this to be a get endpoint that at the ping, with ping there. All right, so let's come back to here. So let's go ahead and create some functions here that will serve this. So let's first create our perform calculation function. So what I'm going to say is def perform calculation. I'm going to take in an expression. I'm just going to call it XBR as a string. And then we are going to provide it with a doc string. Now, this doc string here is actually very important. So in standard Python, a doc string is a piece of documentation that basically helps you to understand, like a human to understand like what the function is doing. And when it comes to a human's purposes, the doc string is more of a nice to have, but not necessarily a must have. In the agent world, it's a must-have. And the reason it's a must-have is because behind the scenes, what these agentic frameworks are doing, whether it's Strands or Crew AI or small agents, what they're doing is they're actually referring to the doc string to understand, okay, this is what the function is actually doing. and the arguments that the inputs that it can take, and then what it eventually returns. And in fact, small agents in particular is so particular about this, they require a very specific formatting for their docstrings. Strands here is not as particular about that. So we're just going to say, in fact, I'm okay with, well, I don't know if I want to do that. So I'm going to say performs a basic mathematical calculation given as a string expression. And then we're going to say it's going to take in some inputs. It's going to say inputs XPR. It's going to be a string. And a string representing, yeah, I'm okay with that. So, and then it's going to returns. It's going to return a float or a string. And the reason it's returning one of the two is because like it's going to return the float value if it can actually do the calculation. But if we have, we're gonna account for some error handling here, and if there is an error, it's going to return the error instead of the string itself. All right, so so we're going to say the result of the calculation or an error message. Okay. All right, so let's go ahead and write the code here. This is not going to be any code. I'm going to wrap it in a try except block here. So I'm going to try. I'm going to say setting allowed characters for safety. So essentially, basically saying we don't want to take any funky characters that hackers might typically use. So these will be our allowed characters, and then we're going to checking for invalid characters. All right, so if not all C in allowed cars for C in expr. All right, then we're going to say raise a value error invalid characters and expression. That's fine. And if it's okay, then evaluating the expression safely. So it's going to say return eval expr. And then just to handle the accept part here, accept exception as E, return error string. Okay, so that is our first tool here. Now, this is just a simple Python function. So how do we actually turn this into a tool that Strands can make use of? Well, like I was saying, with the decorator, it actually makes it extremely easy for us. All we have to do is add a new line above here, and we imported this as tool. So that's all we're going to do. That's it. So that we just created our first tool specifically using for to be able to make use of the Strands framework. All right, so that accounts for one. Let's go ahead and create our other one here. So we're going to say at tool get current date time. All right, so this is again why we were importing date time up here. Now this is hopefully starting to make sense. All right, so let me scroll down, look at my documentation here to see how I wrote this function. Okay, so we are going to say, I didn't want to do that. All right, so we're going to say returns the current date and time in a human readable format. It's not its inputs are not going to be anything because we don't need it. We don't need to pass in anything for that, and then it's going to be returning a string. Yeah, actually, I'm going to just copy and paste my thing here where I did this okay, so basically we're going to, the current time and date formatted as a string. So basically, very simply, that is our code right here. So this is just going to return it exactly how we want to see it as such. All right, so those are our tools. All right, so now we are ready to invoke or go ahead and create the agent, and then we can start invoking it. Now, just to demonstrate how these various agents work, I'm actually going to create 3 variants of agents. I'm going to create, the first agent is going to be bare bones, nothing. We're not even going to supply it the tools. It's going to be our control agent, if you will. It's going to be, because we want to demonstrate how an agent makes use of tools versus not makes use of tools. So that's going to be our first one. It's going to be, I'm going to call it the no tools agent. The second one is going to be our tools agent. So that's going to be the agent where we actually do supply these custom tools that we just created just to see how it works. And then the third one, just because I'm me and just to kind of make things fun, is you can supply a system prompt to these agentic frameworks. And so to demonstrate that, like I typically like to do, we're going to make a Jar Jar agent, a Jar Jar Binks agent. So basically, anytime a final result is produced, it does it in the tone of Jar Jar Binks from the Star Wars movies. I know, I'm silly. So the way that we do that is actually pretty easy. So let's go ahead and create our no tools agent first. No tools agent equals agent. Essentially, all we got to do is set the model. Boom. All right. First agent done. All right, now let's create the tools agent. Tools agent, almost as simple, equals model. Actually, GitHub Copilot got it correct there. I think my face is in the way again. Let me collapse that. All right, so there you go. You can see that we are passing in the model, and then we are passing in a list of the tools. So you can see here that our tools are actually the functions, the names of the functions that we provided, or that we created up above here. And then finally, and I'm going to say jar system prompt. I'm just going to say equals... you are a helpful assistant that uses. All right, so that's good enough. Here, let me move my face out of the way again. So basically just setting a very simple system prompt that will return everything in the tone of Jar Jar Binks from Star Wars. And then we're going to say Jar Jar agent equals agent. Actually, I think that is the correct syntax here. Yeah, so basically you pass in your model, you pass in your tools, and you pass in your system prompt as a parameter like this. So now we have created our 3 agents. So let's go ahead and start testing them out. And I want to test them out with a couple of different kind of examples. So the very first example that we want to do is just what is the capital of Illinois? Did I call tools agents? Oops, I didn't mean to do that. My apologies. All right, so what is the capital of Illinois? So and you can see we got just a couple print statements here. So let's go ahead and run this and see what our results are. Model ID. Oh, did I do something incorrect here? I must have. Model name. It's not model name. Is it not model name? Nope. So, okay, apologies for that. So up in the OpenAI model here, it's not model name, it's model ID. My apologies. All right, so simple mistake there. API key client must be set either passing the API key or by setting the OpenAI. All right, it looks like I did something else goofy down up here. So let me check my notes just to make sure that I didn't do anything wrong. All right, client args. There we go. Missing an S there. All right. There we go. All right, couple just simple little mistakes that I made there. We went ahead and resolved those. So let's see what happens. So it's currently working on the no tools agent response. All right, so the capital of Illinois is Springfield. Tools agent response is probably going to be more or less the same. Yep, just returning Springfield. And then the Jar Jar Binks agent response. I always get a kick out of this. So yeah, in this case, basically what I wanted to highlight here is we asked it for a task in which that our tools were irrelevant. And it was a very simple task. It basically just used the model. All 3 of these are correct. The only thing I was just highlighting here is that the agents will like basically operate the same if you are giving it a task that only requires the agent model. Or the large language model itself. So no problem there. That is all correct. Now this last one did demonstrate specifically how it is making use of our system prompt. So all good here. So let's go ahead onto our other 2 use cases. And let's say I want to calculate a very big number. So I'm just copying and pasting some code here. So, all right, so we have this test prompt. So we have what is this big long number times this big long number. I literally just like cat walking on keyboarded these numbers, just typed out like as many numbers as I could here. And then, so what we're going to do is we're actually going to produce the true calculation here, and then we're going to demonstrate how what the model's going to do here. Now, recall here with our no tools agent that it does not have the tool to actually calculate that. So it's actually going to rely on the large language model only. So let's go ahead and run this. So there's our actual result right there. And the thing that you'll notice here is it actually takes a really long time for the large language model to actually generate this response here. And I don't understand why, to be honest, because this is a very simple prompt. I don't necessarily know what's going on behind the scenes, but in my particular testing, I'm always hitting, somewhere between a minute and 90 seconds on how long this thing's gonna take. So let's just give it a break here, or give ourselves a break here while this continues to run. By the way, drink of the day here so I did go to Potbelly for lunch, and oh my gosh, Potbelly, at least here in Bloomington, has the best Coke Zero, hands down. So if you like Coke Zero, definitely go to Potbelly. But I already finished the Coke Zero, so I went out to the gas station and I got me some cherry Coke Zero. This was I've been calling this my drink of the summer because I drink this basically all summer. Yeah, to the point where I've almost burnt myself out on it. So anyway, so let's allow this to continue to run. Yeah, and then so we'll see what the results are here in a second. I'll give myself a breather and take a sip of my drink. As a reminder, I am taking questions on YouTube or LinkedIn. If you have any, feel free to pop in the chat. I'm glad to answer anything for you. All right. Yeah, this is I almost knocked my drink over. That would have been I would have been so upset because I have so here in my office. My office is actually in my basement. Okay, so it actually did produce the response there, and that is an actually correct response. And that was my experience, is sometimes it would get the response right every time, but sometimes it wouldn't get the response right. Now, the thing I want to call out is so you just saw the second the tools agent complete its response, and you also saw Jar Jar complete its response, and you'll notice here that it's got this thing here, tool number 1, perform calculation. So you can actually see here that the model actually, or the agent actually did make use of our tool here, and it ran much faster this time, and it did get the correct result. But it's hit or miss. Hit or miss in this, so with the no tools agent response, we didn't give the tool, and it was hit or miss on, in my particular testing, on if it would get this right. And in fact, it was really interesting where in the instances where it did not get it correct, it looked very close. But imagine if these four numbers, if these four numbers here that I'm highlighting were not present, but everything else was correct. So the order of the digits was correct, but those 4 digits were not present, so thus the calculation was actually incorrect. So this time the large language model did get it correct, which is kind of surprising to me, but you saw how long it took, whereas the other two were almost instantaneous on how fast it actually performed those calculations. But the other issue that I was seeing is that even with the tools agent, that sometimes it would not actually perform the calculation. It would ignore the tool as if the tool did not exist, even though that the tool was present. In fact, let me go ahead and see if I can try to emulate that again. I'm gonna actually change the model type here to just straight up GPT-5, and just for oops, sorry, I've got somebody trying to call me here. Hold on. Okay, so apologies about that. Somebody just tried. Oh golly, I didn't even notice it. Oh well, my face was in the way anyway. All right, so let me. I'm just gonna comment out this one for now, just because we know that one takes forever. So let's go ahead and restart. Run all. Oh, I should have commented. Oh, I commented out the wrong thing. Gosh darn it. All right, interrupt. All right. I'm going to comment out all of these here just because we've already seen these run. I want to comment out this one just to restart. That's fine. That is fine. All right, so now let's go ahead and restart run all. All right, so we got the actual calculation here. Now, do you notice? Oh, actually it is doing it this time. Okay. Okay. Sometimes what I found is that when I run these agentic frameworks, that it will just ignore the fact that I have this calculator tool that I can make use of. In this case, both times it actually did it. I'm going to just keep running it a couple times just to see if I can actually get it to not use the tool. Okay, so I think this time it's not using the tool. And this is exactly what I'm talking about with agents. You just this is the and keep in mind we were using GPT-5 Nano before, which is a dumber model, if you will. Instead, we beefed it up to GPT-5, and GPT-5 just acted like we don't have a tool here, so we're not using it. And that is the risk of using these AI agent tools: is you just don't know when they are or they're not gonna use it, the tool. Even though within our code we didn't change anything at all. The only thing that we did was we just restarted and reran the exact same code. So that's a big risk. So we'll allow it to continue to run here. So in this case, so it did produce a response. It put a bunch of commas in here. So let me just kind of comb throughout here to make sure that this response is even correct. 954-782-064-268-849-989. 9049. Okay, so that is the correct calculation, but it didn't use the agent. So let's try writing this a third time, just to see what happens. All right, so it looks like in this case it is this time it is using the tool. So this is again the inconsistency factor that I was talking about, and that's a major risk. And there may be things like prompt engineering that I can do to within the system prompt for like this first one to actually say, actually use the tool. It looks like in the jar jar agent example. So if you recall, in the jar jar example, it's invoked the tool every single time, but in this latest case, it's not invoking the tool. This is the nature of working with AI agents. Sometimes they do exactly what you expect them to do. Sometimes they don't. And sometimes you get, fortunately speaking, we've actually gotten the correct answer with everything. But you know what? I am actually interested in increasing the size of this number. So I'm just, cat pawing on my thing here again. All right, so let's go ahead and, I put a question mark in there. I didn't mean to do that. Oh, yeah, I did mean to do that. All right, so I'm going to say, let's go ahead and do this because these numbers are much bigger than the other ones. All right, and the jar jar example is still running. I don't need it to run anymore though. So in fact, I'm just going to halt it. I'm going to interrupt it. Interrupt. It's probably going to say I got to restart my whole notebook. But let's just see what happens if I try to use a much larger number here. All right, yeah, it timed out. No surprise there. All right, restart run all. All right, so that's the actual calculation right there, this huge long number. So you can see with the tool agent's response, it is correctly making use of our tool, and it did produce that's not the same number. Yeah, that's not the same number. What happened there? And did I not copy the prompt correct, or did I not? Oh, I added an extra 8 here. Okay. All right. Yeah, that's my bad. That's my bad. Let's go ahead and try running that again. I was wondering why, what? I used the tool. Why did it not? Okay, now we're getting consistent results. But so, yeah, so it's using the perform calculation. And now let's go ahead and uncomment this because I am curious what result it will get just trying to use the no tools agent. But yeah. So with the no tools agent, you can see that not providing it tools has two issues. The two issues are, number one, you can't guarantee that the calculation is going to be correct because large language models are not inherently set up to do mathematical calculations like this. And then number two is latency. Obviously, whenever these agents make use of the tools themselves, you can see how much quicker the latency is. Whereas if it doesn't use the tool, then it takes upwards of 90 seconds. So let's go ahead and allow this to continue to run. I'm going to take another sip of my drink here. I'm going to check whatever that phone call was. I don't know about you all. I literally get 5 junk calls a day. I mean, it's bad. Yeah, man, I don't know why. It's bad. I get a lot of junk calls anymore. Okay. All right, so it's still working. Still working. I wonder if it's going to take even longer now that I put like a much bigger number in here. Okay, while this is still running, we'll come back to this, but I do want to kind of just prepare ourselves for the last prompt, and that is testing the date and time. So we're gonna ask what is the current date and time. We're gonna ask the no tools agent what it is. We're gonna ask the tools agent. We're gonna ask the jar jar agent. In fact, I'll go ahead and queue it up. So while this is continuing to run, so dang, we're upwards of almost a solid 2 minutes, or yeah, over a solid 2 minutes on producing this response here. And I'm a little bit more skeptical this time that it's going to get the response correctly. The large language model, that is. Oh man, this is taking a really long time. I don't know how long I want to let this run. Yeah, but we are coming up on the end here. Once we do this final prompt here, I'm going to call it. I got to go pick up my kids from school. Today was picture day. My daughter's dressed up super cute. I love my girls. Looking forward to getting those pictures back. Wow. I can't believe it's taking this long. What model are we using? I can't even remember. Oh yeah, we're still set at GPT-5, so we're not even at GPT-5 Nano anymore. All right, I'm going to let this go as long as 5 minutes, and if it goes above 5 minutes, then yeah, I'm killing it. I hate leaving dead air and silence, which is why I keep talking and like interjecting here. Because yeah, I'm sure that nobody is interested in watching a stream where I'm just like watching this thing continue to produce its output. So what do I want to talk about now? I could talk about what I'm doing this weekend. Not a whole lot. Got a nephew's birthday party tomorrow. Been playing Hollow Knight Silk Song. I did, for those of you who are also playing Hollow Knight Silk Song, I did see the credits roll for the first time. Now, no spoilers, but I am anticipating that what I saw was just like the first ending. So if you played like the original Hollow Knight, you'll be aware that like there's multiple endings. Like there's like the bare bones ending, and then like you got to do some advanced stuff to get like the other endings. I think I saw the very first ending, and that was after 38 hours. So definitely got my money's worth out of that game for it being $20 and putting that many hours into it. Yeah, and I've also started to play Borderlands 4, and it's pretty fun. Yeah. All right, I'm giving this another 30 seconds, and if it doesn't work out, I'm killing it. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, I give up. Okay. All right, so I'm giving up on that one. Let's go ahead and comment this out, and just to see if the other, if the tools agent and the jar jar agent will perform a little bit better here. All right, so let's go ahead and run all. All right, so there's the actual result, and it appears we'll find out here in a second. Okay, so the tools agent did know to use the tool. All right, did get the answer correctly there. The jar jar agent, are you gonna be intelligent enough to use the tool? Okay, and the jar jar agent is intelligent enough to use the tool. And there we go. Yep. And that is the value of setting tools within a tools agent to do calculation. All right, so that demonstrates that. So let's go ahead and down to our final use case, and that is asking what the current date and time. So let's see what the no tools agent has. So you can see the no tools agent, because it does not have any tools, it knows the date, which kind of is a little bit concerning to me, because I thought the APIs, specifically the APIs, did not have any sort of system prompt behind the scene, but apparently there is some sort of system prompt for the GPT-5 that actually knows the date, but it does not know the time. So you can see here that with the other two agents, that it did correctly invoke our tool. tool, and it did know that yes, today is September 19th, and the current time is 1:58 p.m. And you got the Jar Jar version. Man, I would. Yeah, I'm not gonna do the voice. I've never done the voice, and I never will. At least not on stream. I actually can do like the Jar Jar impression, like off stream, like kind of well, but yeah, I'm definitely not doing it on the stream. So yeah, that really just covers, and that's it. That's the agent. I guess. What do I want to show here? So we have this response object here. We talked a little bit about telemetry, or I'm sorry, more specifically AI observability. So with this response object, we can actually look at the trace of what happened. And I'm trying to remember how you do that. I'm gonna have to go back to the documentation here and see how you do that. Agents, tools, no, model provider. I can't remember where it's at now. Examples. Here, let me just search strand, agents, trace. All right. Trace metrics. That's what I was looking for. Metrics. All right. And so how do we actually look at the metrics again? Tool metrics. Okay. Yeah, this is what I was looking for. This line of code right here. Response.metrics.get summary. So you can see here that we actually can see that we had 4 tool cycles, and it'll actually tell you, it used this tool. When it used this tool, the average invocation time was this long. The success rate was this. And then if you look throughout this entire thing, basically, like, the nice thing about strands here is that it will give you the full like trace. Yeah, that's the precise word I was looking for. The full trace of like what actually happened here. And it's just as simple as running this .get summary. And I think if I just did a traces here, it'll get just the traces only. Yeah. So you can see here with the cycle, that how many cycles did it have? Okay, so it had 4 cycles. So let's actually review the cycles here. All right, so cycle 1 here, it is actually checking to make sure that we are going to use the tool. And then if we go down to, where's cycle 2 here? So cycle 2 here is, all right. Oh, it's just noting. Oh, I forgot that it actually keeps track of the traces of everything that it did. So you can see the reason it's got 4 cycles is it's counting for the two that we invoked whenever we wanted to actually produce the response around the calculation. And so you can see here, that's what this is doing here. And then if you scroll on down further, then you can actually see the trace of when it actually wanted to do the current date time. And so then we got the current date time. So this was the result of our tool called here. And then whenever you actually go down to cycle 4 here, it's actually used the large language model to use this date as an input to synthesize the final response from the large language model. Okay. All right. Cool. All right, that's it. That's all I wanted to cover today. So in future streams, I want to go a little bit deeper. I want to talk a little bit more about memory. We talked about the spectrum of AI agency at a high level. I think I want to dedicate a full stream to that, specifically because like I want to harden what I mean by the spectrum of agency with specific examples. So we're actually going to code up, here's what like a level 1 agent looks like versus like a level 4 agent, those kinds of things. So, but like I said, I got to run up to the school to get my kids. So we're going to call it here. Hope you enjoyed the stream. Yeah. It's good to get back in front of the camera here. It's been a while. So I will see you all in the next one, and I hope you all have a great weekend. Thank you.